good afternoon, everybody. We had a little bit of technical difficulties, but we're up ready to go. Everything should be good. This is AMSI, how Windows 10 plans to stop script-based attacks and how well it does it, with Nikhil Mittal. Mittal.
Yeah, that's fine.
Mittal. You are in Mandalay Bay, GH. Just got a couple of quick announcements. If you haven't already, stopped by the business hall in the Bayside AB. That's downstairs. Anytime during the day, or especially during the welcome reception from 1730 to 1900. Also, the Black Hat Arsenal is on the Palm Foyer on level 3. A lot of good stuff to check out up there. And then join us for the Pony Awards in Mandalay Bay BCD at 1830. And if you haven't already, please take a minute to set your phone on silent so that it doesn't interrupt the presentation. Thank you. Nico.
Thank you very much. Thank you all for coming. Welcome to the session where we discuss AMSI. Let's get started. A couple of things about me first. My name is Nikhil Mittal, that you all know up to now. You can find me on Twitter as NIKHIL_MITT. I'm a sucker for Twitter followers, so please go there, follow me. I blog on labofapenetrationtester.com. You can check that out as well. All of the things which I work on, I generally like to write a blog about them. I maintain 2 open source toolkits, which I think are useful for penetration testers and good attackers. Kautilya and Nishang. Kautilya is a toolkit which you can use for using human interface devices in penetration tests. And then there is Nishang, a tool which could be used to which is a collection of offensive PowerShell scripts, scripts which you can use in penetration tests and red team operations. I'm a penetration tester and trainer by job. I'm an associate consultant with Not So Secure. I've spoken at a couple of conferences before as well, DEF CON, CanSec West, ShekaCon, and actually a few more. So we are going to discuss in the class script-based attacks. What are they? How attackers use it, why they are used. That's going to be the start of the class. Then I'll introduce you to AMSI, what AMSI is, why it was involved or included in Windows 10, what are the benefits of it. We'll see its detection capabilities of AMSI. We'll see what were the failed attempts when I experimented with bypassing it. So I experimented it blindly as well as with some mind applying to it. So results may vary. And then we'll see how we can actually bypass AMSI, what are the ways, how we can avoid it, bypass it, unload it, things like that. And that would be the end of the talk. So script-based attacks. AMSI generally wants to target 3 kind of things: PowerShell, VBScript, JScript. I am more interested in PowerShell. I got started with my affair with AMSI started when I was testing a couple of my scripts on a Windows 10 machine, and they were still getting detected in memory. So as any good attacker, I generally avoid to touch disks. So if the attack script gets detected in memory, that's really heartbreak. You try to stay in memory just to avoid detection, but you still get detected. So that the kind of feeling, the betrayal which I got by the hands of Windows, that's where I started to look more seriously into AMSI. PowerShell, I specifically want to focus on because this is the most modern thing or the latest hot thing in the Windows post-exploitation scenario. And that's why it's really imperative to, one, learn to use it. That's what I'm doing right now. Second, if there is something which comes between you and your beloved PowerShell, then just eliminate that thing. Why do we use PowerShell? First of all, low rate of detection. Still, even after AMSI, compare any executable and a corresponding PowerShell script, and you'll know what I'm trying to convey here. If you can use a PowerShell port of any tool you have, or just use some awesome scripts out there to load your executables in memory of other processes using PowerShell, and then use it. So that's one thing. Because of really low rate of detection, that's the first part. And then PowerShell attacks are very effective. It is something which is already there on all modern Windows operating machines. Windows Vista onwards, you won't find any Windows machine which has no PowerShell in it. They all come preloaded with PowerShell, different versions. So that's it about it. Another thing with why I like to use PowerShell, it is used by system administrators. That means you can actually try and stay off the radar because you may mix with the actual normal traffic in an environment or normal scripts which are being used. So that's the second reason. It provides access to a lot of OS and network things. For example, using PowerShell, you can access WMI, .NET registries, Windows API, not .NET registries, my bad, Windows registry, .NET classes, other machines on the network. You can interact with so many other machines on the network using PowerShell remoting or using WMI from within PowerShell. You can interact with this. So there are certificate stores on Windows machines that you can interact with using PowerShell, file system, whatnot, COM objects, so many things are there. It is the future of Windows administration. I think in Windows 2016 CTP, if you run a nano server, I believe that it is possible only to manage it using PowerShell remoting. So that's why. Another thing, the last one is actually why I started using PowerShell. Antivirus vendors usually, up to a couple of years back, no one actually cared about PowerShell, at least on the Defender side, on the endpoint security side, no one was actually worrying why PowerShell is being used. There were scripts. Me and other guys who used to write PowerShell scripts, our scripts were not getting detected at all. At least for me, there was no detection. I was feeling ignored, but then it turned out that they didn't care for anyone. So these are the reasons why me personally and some of the good attackers I know love to use PowerShell. How do we use it? First way is to execute scripts from disk. But as soon as you touch disks during any good penetration test or attack, you risk getting detected. As soon as you touch disk, it's like you're inviting countermeasures to come and see you. Say, hey, I'm here, can you see me? So that's the kind of thing you are doing as soon as you touch disk. Then there are ways of executing PowerShell scripts or any kind of attack from memory. PowerShell provides you some really interesting ways of doing all the attacks just from memory. So once there is an encoded command option which comes with PowerShell, you can actually use it to load PowerShell scripts and commands in memory in base64 encoded form. So you have a good chance of avoiding detection generally, at least by traditional antiviruses and endpoint security measures. Then there is download string cradle, which I believe actually triggered the introduction of AMSI. So there's something like which I think I'll show you as well, if everything is fine. I had a problem with this machine connecting to the projector. So then there's a thing called download string cradles where you can actually pull a script from somewhere from the internet or a web server, loaded it completely in memory as a string and execute it. So that's the most abused part of PowerShell and .NET interaction. And I frankly believe that's one of the triggers why AMSI was introduced, just because this thing was going out of hand. And then there is reflection, which many of you may know, but I'm not going to discuss it. I'm not well versed with it actually. And that's what we are not going to cover in the talk as well. So with all this thing, one thing is clear, that detection is easier for disk. Obviously, when you touch disk, if you save your scripts on the target's disk, there are so many ways they can be detected. There may be, I don't know of anyone, but there may be some antiviruses which run your scripts in a sandbox, PowerShell scripts. I'm unaware of any, if any of it is doing it. But since there are so many ways it can be done, that's easy. That's just something we are not going to discuss. How do we stop execution of scripts from memory? That's the question. And that's where AMSI steps in. So according to Microsoft, so this has been pulled out from different blog posts about AMSI from Microsoft. The references are there in the slide notes. As per Microsoft, AMSI provides file, memory, and stream scanning, content source, URL IP repetition checks, and other techniques. So because it is not really well documented up to now, the developer documentation is there, but the user documentation is, at least as far as I know, is not extensive up to now. So I don't know what these other techniques are, but still, at least I have messed up with this stream and memory scanning. I've seen this thing. That's the thing we are after. So also, according to the blog posts by Microsoft guys, it can be integrated into any application. And any application can call the AMSI, can call the AMSI functions, and they in turn can call whatever the endpoint protection mechanism is being used. So that's the idea how it works. It is also claimed that it includes additional calls for scripts that use obfuscation or layered dynamic code evaluation. That means that if you use any kind of obfuscation, it should be less helpful, which in my experiments turned out to be interesting actually. As of now, when I was writing this slide on 21st of July, only Windows Defender and AVG, some version post 10, only those two things were using the AMSI. So there's one interesting thing. There are certain antiviruses or endpoint security measures which use stream scanning already. AMSI is sort of a game changer because it comes turned on by default on Windows 10. So as soon as something is by default on Windows, it's something which is widespread. So if we cannot bypass AMSI, then I may be looking for some other job. Being a PowerShell guy, if I'm getting caught in the very first step of my penetration test, that's a disaster for me. So this is how AMSI's architecture look like. The only thing I want you to look at right now is this one, where, so it's sourced from PowerShell, the source is there, source from Microsoft, my bad. So from PowerShell, if you try to execute a script or a command which AMSI thinks, so this is the scripting engine of PowerShell, there are calls to the AMSI, and then whatever the endpoint security mechanism is there, that can have a look at the unobfuscated script which was submitted by the PowerShell's scripting host here, which in English is whatever the input method is, whether it is interactive or you load it from disk or from memory or whatever way, when the script goes to the scripting host, unencrypted, unobfuscated, plain clear code, then it is submitted to the antivirus or endpoint security mechanism in use, which as per Microsoft, as per the blog post from Microsoft, I've not talked with Microsoft directly, which as per the claims made already should be measured on signatures as well as behavior. If it is encoded, if there are any interesting things which it is trying to do. So that's what it has done. Also, because of this thing, if you use system.automation.dll, that is, you do not use PowerShell.exe actually to execute PowerShell scripts and commands. So that sounds a bit weird, but that's used by so many tools, and that's perfectly all right. You can actually execute PowerShell scripts and commands without having to use PowerShell.exe. Even if you do that, AMSI steps in and catches the scripts. And because of the claim, I have found this less help from obfuscation a bit weird. I mean, basic obfuscation it was not possible to bypass things using basic obfuscation. And if we go back to this slide, it claims that it includes additional calls for scripts that use obfuscation, which made me write this. But after writing this slide, I tested things in detail. Some of the results were a bit more interesting than I expected. So let's have a look at the AMSI detection. What we are going to have a look at in this demonstration is I'll turn off AMSI onto the VM on my box, and then I'll try to pull invoke mimikatz from a local web server. It should get detected. It should not get detected. Then I'll turn on AMSI, and then I'll try to pull that script, and it should get detected. So that's the idea of this demonstration. So, okay. So what I'm going to do now is using this commandlet, which we are going to discuss later on as well. So I'm not going to increase the font size. That's for me, not for you. So I'm going to disable AMSI or temporarily disable it. That's the point. Okay. If the machine cooperates with me. Come on, demagogues. Okay. So what this command does, it disables IO-AV protection. That's whatever whatever the memory scanning is being done by Windows Defender. That's we have disabled that. I'll need a minute here. Let me just run. Yeah. So now that's a local web server, please do not fuzz it, that's really poor one. So if I now try to access this script from memory, let me copy this. So we won't see anything interesting, just that invoke maybe gets executed. Gets executed, no problem. The thing which we are interested in right now here is this. Was there a threat detection? Let's have a look at that. So let's have a look at the latest threat. So no, so the time on this machine is 9:56. I don't know on what time zone this machine is, but the last detection was on some other date altogether. That means there was no detection. And if I turn the disable back, I turn it on back, and try the same command from a new service or new session. Okay. So now if I try to run the same command from a new PowerShell session, you can see that, so this is for you, so I can increase the font size now. So here you can see that we got a message that this script contains malicious content and has been blocked by your antivirus software, which is quite good. And if we go here and see the detection, I think believe it's updated already. You can see that we have a detection on this date at this time. And please have a look at this resources module. It's AMSI which caught us. So this was actually the first time where I saw AMSI. Okay, don't want to send anything. This was first time I saw AMSI in action actually. So this means that as soon as we turn on AMSI back again, there was a detection. So let's just stick at this one demonstration here. So now what if, so this was a really lame execution. Just from an interactive console, we tried to execute a script, and that was caught. What if PowerShell scripts are loaded from unusual places like WMI namespaces? You can actually save scripts in WMI namespaces or from registry keys. Or what if you are loading scripts from event logs, using some existing logs which get created. You store a script in chunks in event logs, load it back from event logs and try to execute it. Traditional antiviruses during my tests it was not possible for them to detect these things for obvious reasons. But AMSI still caught these things because no matter what the script came from, what was the place or the method of input, because it was submitted in clear text to the scripting host, at that time, AMSI stepped in and detected these things. Now, that was unusual storage. What if we talk about unusual execution? Unusual execution means without using PowerShell.exe, there are tools like NPS, PoundShell, etc., which use system.automation.dll or other methods to execute PowerShell scripts without using PowerShell.exe. Well, will they be caught? Yes, they were caught as well. Then reflection, even in case of reflection, where I used existing tools because I suck at the context of basics of reflection, so I used ready-to-use tools for that. In that case as well, detection was there. And then there are application whitelisting bypasses. I recently worked on these things. Casey Smith worked on these things. I just copied these things. So I tried on that on these things as well. Once again, detection was there just because as soon as there was something sent to the scripting host, that AMSI stepped in, detected it, and I was not a happy panda, I was a sad panda. So let's have a look at one of these things. If let's skip that. I think I'll overrun. If I don't overshoot, I'll come back to this. So what I planned to do here was I'll create a SCT file which pulls once again invoke mimikatz, and then I will use regsvr32 to execute that SCT just to try if AMSI could be bypassed. You can guess that it was not possible to do that. So as a red teamer, I was not really happy. I started looking for different ways to bypass AMSI. And interestingly, it's not me who came up with the smarter ways of bypassing thing. It's the other guys. I'm just going to talk about it. So still, if you use PowerShell version 2, if you have a look at the version of PowerShell which comes up in Windows 10, that's I think on my box it's V5. On a Windows version 5 box, if you have the capability of running PowerShell version 2, AMSI has no way of stepping in if you're using PowerShell version 2, and that's a known thing. The only drawback of this thing is that needs .NET 3.0, which does not come enabled or installed by default on Windows 10 boxes. I have seen a couple of Windows boxes in enterprise environments during my penetration tests. Many times there is .NET 3.0 installed for, what's the one word which makes Microsoft's products suck security-wise? Exactly. So it's backward compatibility because of some application which could not work. So I love Microsoft's, how Microsoft responds to things. I'm going to talk about it as well, how Microsoft's guys and engineers respond once you're trying to break their things. It's awesome. It's been a great change for me at least. So because of backward compatibility, I have seen .NET 3.0 installed on so many of Windows 10 machines, but still because it is not there by default, we can assume it's not fair to say that we can bypass or we can use PowerShell version 2. That's okay. Another way is to significantly change signature of your scripts. If you have the capability of writing the same functionality with different signature every time, that would be awesome. But that's generally not possible. So, and the third way is to just disable it altogether. Go really brute on it, unload it, kill it, disable it. That's the third way. So these are the three ways we are going to discuss. First way, signature bypass. So when I started working on AMSI, I thought very high of it because all of my payloads were getting detected. But when I started testing, it turned out that this thing is still created by mortals. It is still possible to bypass things on AMSI. This was actually really interesting. I was discussing this with my colleague Anant a couple of days back, and shout out to him if Anant is here. It's his idea to do this obfuscation thing manually, and it was possible for us to spot that what exact signatures AMSI uses, at least in case of one of the scripts, and how we can just simply change the functionality or remove the functionality and still see what AMSI is looking for. So this is how manual obfuscation goes. Remove the help section. obfuscate function and variable names, maybe just replace them by some weird characters or just by numbers. Then encode parts of script. That was actually surprising for me because it was claimed that AMSI actually have additional calls. Maybe that I understood that in a different way, but it was claimed that if there are additional calls if there are obfuscation or encoding techniques being used. But that's the third thing. And then profit, script will not get detected. So there is one way of doing that's use manual obfuscation, do it manually, but it is really not possible for huge scripts. What I found out ready to use was there is an ISE. ISE is the editor which comes built in for PowerShell scripts. So there is an add-on for ISE called ISE Steroids. There is an obfuscate functionality built into that. Just use that and you're good to go. At least before the anniversary edition, I've not tested these things on the anniversary edition. So please do not stand up after a talk and say that these things don't work on the anniversary edition. Not tested. Every testing was frozen, I think, on 15th or 16th of July. And even, I don't think the anniversary edition was there at that time. Okay, so this is a screenshot of how obfuscation looks like. I think this was not the manual one, but from the ISA steroids. And this is for one of the scripts from from the tool which I have written, Nishang. So this was not caught by AMSI. I would like to demonstrate this first. So okay, so what I'm going to do now, I'm going to disable Windows Defender so that I can pull invoke mimikatz.ps1 onto the disk. I will obfuscate the script and then re-enable Windows Defender, and we'll see that the original one, the unobfuscated one, gets detected, but hopefully the unobfuscated one doesn't get detected. So let me quickly do that. So what I'm looking for is PowerShell ISE. And meanwhile it loads, let me disable real-time production at all. So I'm disabling real-time monitoring. Okay, it's gone. Now let me quickly pull invoke mimikatz. So you can see that there is a notification to the user. Okay. So I'm now downloading invoke mimikatz and it's there on the disk. Here it is. Okay, so there is an obfuscated one already. Let me remove that. Now I'm loading the ISE steroids. So that's the automated one. After this, I think we have time. I'll show you the unautomated one as well, how we spotted that it can be done manually as well, at least for smaller scripts. So, tools, obfuscate, just use the default options, just try to save obfuscated script. So it feels quite script kiddish that you're just using the tool. If you want, I can explain it to you later on. So this is the obfuscated one. Let's close this. And let's turn this thing back on. Now let's wait if anything gets detected. Or maybe let's just try to load these things and see if Windows Defender has a problem with any of these. So downloads. Let me try to load invoke mimikatz first. Okay, it found it. Not letting me load it. Okay. So if I try to load invoke mimikatz.ps1. So this is not from AMSI. This is from Windows Defender. You can tell it from the error message. But if I try to load the obfuscated one, it will get executed. So that was actually really interesting. So because we are not running with administrative privileges, we are not able to see anything here. No, I don't want to send anything. Because it was not, we are not running with administrative privileges, we were not able to see anything, but you can see that Mimikatz was at least executed here, which is very interesting. Because once again, the claim was that if you employ obfuscation, there would be more calls. It could be me, but the kind of vibe I got from it was that if you use obfuscation like this, the thing which we have used here, you use base 64 encoding for various functions, there should be something special there. Turned out it was not. And for the manual one, let me see if I can quickly show you that as well. So there is this script in the tool which I wrote, Nishank. This is called Gupt backdoor. That means a secret backdoor. So let me quickly pull that onto that machine. And if I try to pull it using the command, I hope it's still there. So it gets detected as a malicious script. But interestingly, so I'm assuming that in this case, it could be because I'm going to remove all the functionality just to zero in on a signature. So if I just remove all the help from here and all the functionality as well. So what we have right now is just the function name and two variable names. So now, okay, so this is really inefficient, but I like to do it this way. Now I'm going to remove the file from this place and copy it back there. So now if I run this, it still gets detected. But let me replace this with 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 1, 2, 2, 3, 3. 7, 7, 8, 8, 9, 9. That's it. Let's now quickly test this once again. Now if we run this, it doesn't get detected. So that's how you spot on to the signature. That's really basic obfuscation, basics of, I'm not really good at these things. This is the first time I'm doing these things just to bypass AMSI. That means that most probably, even if you imply obfuscation or encoding, AMSI up to now it doesn't care, or when AMSI submits it to Windows Defender, maybe it's Windows Defender who does not have signature for these things. That's the thing actually I was unable to zero in on. I tried a lot, but couldn't make out why this thing was happening. So maybe if anyone of you knows better than me on this, obviously there are guys, just catch me after the class and please educate me on this. So in any case, using these simple ready-to-use obfuscation or just simplification, it was possible to bypass or avoid AMSI. Now there are three more ways. One which we have seen already, set MP preference. That is using that's specific for Windows Defender. That is the built-in commandlets which are there. For managing Windows Defender, you just use them and you're good. Then unload it from current process. That's from Matt. I can't pronounce his second name. That's why I call him Matthew. This is the guy who wrote Papasploit. Awesome guy. So that's from him. I can't even ask if he's in the class. He's in the talk. And then this is by another friend whose name also I can't pronounce properly. So that we are going to have a look at as well. First of all, if we use set MP preference, so that's the built-in PowerShell commandlet for playing with Windows Defender. And that's the thing which we used just now. That is disable real-time monitoring. If it is set to true, then what happens? Obviously, real-time monitoring gets turned off. Ta-da! But it shows a notification to the user. And that we saw already, that there's a notification to the user that please turn on your antivirus security. Things with these, it needs elevated privileges, which is actually not a thing. We are discussing almost a post-exploitation scenario, and getting administrator access in Windows environment is not really something which needs a lot of hard work. But there's a thing with the PowerShell version 5, or I should say WMF version 5, that it loves to log a lot of things. Not in this one. Here, because we are disabling a feature or a protection of Windows Defender, there will be a log in Microsoft Windows Defender operational event ID 5001, and it clearly says Windows Defender real-time protection was disabled, which is not a good thing. I mean, it's almost equivalent to writing things on disk and trying it out. Now there is another way. That's the thing which we used in the very first example. That's to disable IOAV protection, setting it to true. That allows us to do interesting stuff as well that we saw already. This doesn't show any notification to the user, a bit more stealthy. Once again, needs elevated privileges. That's fine. Once again, there is an event ID in the Windows Defender logs, which we do not want. So the log says Defender real-time protection feature configuration has changed. So in almost all organizations, both of these events will trigger an alert. Now comes a really interesting method. This one is which Matt, okay, I forgot to add the screenshot, it's there. This one is by Matt, and this actually unloads AMSI from the current process without administrator privileges. So this is something which I found really interesting. Once again, no notification to the user, and no logs by Windows Defender or anything. But here's when the automatic logging feature in WMF5 steps in. Because this thing is interesting, it gets logged by default. And that's something which is a bit of a headache. If your organization or any of your client's organization or whatever you are responsible for logs these things and then analyze these things, then you may still catch someone who's using this method. The interesting thing with this method is, once again, you do not even need administrator privileges. That's for one. That makes it ideal to be used with client-side attacks. That is, you may not have, I wish as an attacker that it was possible to have people running their MS Word or Excel or other Office products or their browsers with administrative privileges, but that's not the case. That's a sad reality. So this thing allows us to execute different interesting attacks from client-side attacks as well. No administrative access required. But automatic logging steps in. So what should be the next step? Shall we bypass the automatic logging? Now, I'm not going to discuss that in the class. Sorry for raising your hopes, piquing your interest. We are not going to discuss that in the class, in the talk. Sorry, I just did 4 days of class, so I keep saying class and class again and again. I'm so sorry about that. So another method of unloading AMSI was discovered by a friend, Cornelis de Pla, and it is implemented in his tool PoundShell. So I have that on that machine, but I'm not going to demonstrate it. I want to save some time for questions and answers. I believe there would be some interesting ones. What this technique does, it moves PowerShell.exe to a directory from where the tool is loaded and executes it from there. As soon as a PowerShell.exe is called, it looks for a DLL called no points for guessing AMSI.tll in the current working directory. This tool provides a fake DLL to that, which just loads and exits. That's it. AMSI does not step in anymore for this tool. Now here's the thing with this. Once again, this WMF5's automatic script block logging steps in, because what this tool does is it has picked up some really interesting scripts from so many open source PowerShell tools and load them into the memory. As soon as AMSI is off, it is possible for it to load all those scripts. As soon as those scripts are logged, this log is for those scripts. But in any case, there is logging for this. Once again, So this is actually something which I expect the audiences to do for me, bypass the automatic logging. So now what I'm going to try to do is run a client-side attack and see if it is possible to bypass AMSI from a client-side attack. So that's something which, as an attacker, I would always like to do. That is, so there is no need to go about more and more about client-side attacks. It's generally the thing which provides us the foothold machine in any good penetration test. So let me quickly do this real quick. If my Kali box is still alive. Okay, all my machines are dead. Okay, so I have, let me do this really quick. I have this. Okay. So I'm going to start a Metasploit listener real quick and try to get a Metapredator session back on that Windows 10 machine, simultaneously bypassing AMSI. So that's what I'm trying to do now. So meanwhile it loads. Let me see if I have the setup there. Okay. So trust me that I have created this Word file using the command pasted in the notepad. I'm not going to do it again. I need to save time. So I hope you guys trust me that this is a proper one created using one of, okay, I'll do it. No need to explain it that much. So let me copy this real quick. And I'm going to load this client-side attack utility from Nishang. Okay, outward, which generates weaponized or loaded Word file. So if you can see here, what I'm doing is using Matt's method of bypassing AMSI and then pulling this MSF payload.ps run from my local web server and executing it. So we have a file called salary details.doc here. Okay, the font is smaller. I'll just, okay, set payload, Windows x64, Metapredator, reverse TCP. And let me set the L host real quick. That is going to be 192.168.230.154. Okay. That should be it. So we have a listener here. And if I try to open this on this target machine. So let me see if I have MSF payload.ps1 here. So there is this warning which no one reads. Yeah, okay, that's good. Let me enable that content and let's see if we have anything here. Okay, meanwhile the session loads. Let's see if there was a detection. So where is detection one? Let's see. So it's 4:13 a.m. on that machine. And the last detection was at 4:02 a.m. That means it was not detected, and hopefully so it could be, oh, it's a wrong payload. It's wrong payload. It was supposed to be, oops, reverse HTTPS actually. Okay, let me try this real quick once again. Okay, it's there. So that's 230.16. So now what we have here is a Metapredator on a Windows 10 machine. That's the latest build at the time of writing. On a latest build, we bypassed AMSI, and that's all I think we could do while bypassing AMSI. So that was it. couple of words about WMI F5 autologging. It's now hard to execute a PowerShell attack on any Windows 10 machine or any machine which has this running, so this is a big compliment. I don't think it is really possible. There are ways to bypass it. I know a couple of guys who can still do it. Not leave a fingerprint and still perform a PowerShell attack. That's really not possible. And apparently all the obfuscation technique, it boils down to bypassing this log, and if someone is monitoring logs, that's going to be an interesting thing. A quick 10 seconds thanks to guys from MSRC, and I don't know if I can take names, that's why I'm not taking names here. A couple of guys from Microsoft, more than 2 guys, talked to me on Twitter about this. Very good response, very forthcoming. So that's a big change, at least for me. So we can conclude that AMSI is still a big step forward when it comes to Windows security. At least things are going in the right direction. But it is still possible to avoid AMSI or avoid detection using already known methods and techniques. And that's something of a downer here. And it's no silver bullet. It's only useful when someone is monitoring the logs and you use or follow the basic enterprise security measures. And that's all. These are my contact informations, and all of these slides or whatever code I have would be available on my GitHub repository. That's all. Thank you very much. Questions? No insults, please. Well, so if you have no question, that means either the session was really good or really bad. So I would like to assume that it was really good. Thank you very much.